So I will just start. I will just see once the does does anyone have questions? Rajdeep, you are raising hands. You can chat. No, okay. I think it's fine. So I will start now. So before starting, I'm going to just say you that today's first session will be fully theoretical. Day one, day two, and day three will be on hands-on project on machine learning. So today's session will be fully theoretical. So let's start. So saying about myself, my name is Rishi Bhattasali. I am from CACIML third year. So if you want to know more about me, LinkedIn is the best place to know now. So here is my profile. And if you want to know more about me, you can just visit my portfolio. Here it's my portfolio. I'm just scrolling it down through. Okay. And if you want to see like more projects, here it is my GitHub link. You can go. So for the next one, Ayush, I will give it to you.
Hello everyone, I am Ayush Agarwal, a second year student from CSDS. If you'd like to more know about me from my background or connect professionally, feel free to check out my LinkedIn profile.
Just a second.
You can check out my LinkedIn profile.
Just a second.
All right.
Hmm. This is just scrolling it down through.
My GitHub is also linked there, so if you want to check it out. With that said, let's dive straight into the event.
Okay, so let's start. Just a second. Okay, now let's start. So I will just start with very basic as said. So let's start with the definition. Machine learning is a field of computer science that uses statistical techniques to give computer systems the ability to learn with data without being explicitly programmed. Now, to be precise, machine learning is nothing just the learning from data. And here a word is mentioned like explicitly programmed. I will now explain you with an example now. Suppose you are given a task to predict whether a mail is a spam or ham. In case if you don't know ham is just an authentic mail. So suppose you have your right to given a program. If you write a program with C or C++, suppose you get to know when just whenever the word like huge or discount words comes like more than two or three times, it is basically a spam mail. But suppose the company gets to know your logic, so then you have to constantly update your if else condition, and it will be a just tremendous task. But in machine learning, you don't have to do so. Machine learning, and that's the beauty of machine learning. What you do with the machine learning is you train the model with the data sets, and the model will give you an output. You have to do nothing. So just what can you build with machine learning? I just said you one example, that is spam classifier, and the next is image classification. Image classification also. And here also I can just give that example. Like suppose you have to predict whether an image is a cat or dog. If you are to writing that coding logic in C++ or C or Java, suppose the number of features you have to write, like the ear size, the eye color, the skin color, and whatnot. But in just machine learning, you train the model with the tons of data, and it will just give an output whether it is a cat or dog. Now coming to this diagram, you can just explore this in more of this. Now coming to this diagram, I will start with the machine learning. Now machine learning is nothing just I told, it is consist of multiple algorithms. You train on the data and it will give the output. And about deep learning is basically the image classification of types. Like I told you, like dog, cat, sorts of that. That's a deep learning. And AI is a consists both of machine learning and deep learning. Means it is actually a total connection between the model, algorithms, and front end, and total product. And what is data science? Data science contains all these deep learning, machine learning, AI, and also some of its more its unique, some unique state, unique features like data mining and all those. So this is just about machine learning. I will next go to the next. So today's agenda is types of ML, key concept of terminology, machine learning and workflow, overview of algorithms. So going to the next page. Now types of machine learning. So basically there are four types of machine learning. One is supervised learning, there is unsupervised learning, there is semi-supervised learning, and there is reinforcement learning. What does the supervised learning say? A model is trained using a data with known outcomes to learn how the features relate to the levels for classification. Now I will give you an example. Just a second. I have done something. Suppose these are the like columns, like this one is the IQ, this one is CGPA, and this one is placed. Just forget about this one for a moment. It says like for 68 IQ, the CGPA is 7, and suppose it is placed Y. Placed means Y means yes. So like this, there are numerical rows. And what does this supervised means is it contains the input columns also. Here input column is IQ and CGPA, and the output column is placed. And so like this is the basically supervised learning. And from the next, you just put any IQ and any CGPA, and the model will automatically tell you that whether you can be placed on it. I just gave the rough example, and I will just explain one more thing. Here you say that the output is either yes or no, yes or no. So like in where the output is just like categorical variables, like it can be more than two also, but like just category like yes, no, or high, medium, low, like this. Then it is called a classification. And if it contains a numerical feature in the output column, like you say 12, 10, 0, or anything random, then it is called a regression. So in supervised learning, there are like two major subdivisions. Here you understood the classification, and here is the regression. So coming to the next one. Now, what is unsupervised learning? Unsupervised learning is just nothing like supervised learning only, but there will be no output column. So to give you an example, I will try to draw something to make you understand. Okay, suppose this one is X column, this Y column. Pardon my drawing is very bad. And suppose in the X column we have age, and suppose in the Y column we have take it expenditure. Now I will just plot some data, just random data. Now what happens in the supervised learning? Suppose there are just two columns like expenditure and age, no output column. What you do in the unsupervised algorithm is you make clusters of this, like this. There is one cluster, this is one cluster, and this is one cluster. Now what you can get from this like graph, see, like if the age is small, like little, the expenditure is the least. And if the age is like the where is a young generation, the expenditure is more. The like the group of people, it tends to expend more. And if the like age is towards suppose retirement, then the expenditure becomes a little less. So from this we can just find out conclusions that young generations tend to spend more. So like company can get the data and just use coupons and promos for all the young generation instead of the retirement generation, all this is the just basic example I gave. There are numerous tremendous examples of this. Companies are highly using that. So let's go to the next one. Now semi-supervised learning, as you can just eh, understand from the word only, that semi-supervised consists of both supervised and unsupervised. One beautiful example I would like to give you is in Google Photos. Like you have must have noticed that some suppose there is some person X, and the you label that person someone you know, And like whenever a number of photos come, the person the person images gets automatically labeled to the X. So you don't have to do anything, you just once you have to just label once that that is the person X, and after that automatically all photos go onto the labeled X. So this is about supervised learning. I gave you an example. Now reinforcement learning. Okay, I will give you example on this also. Suppose you are training a dog, and suppose the dog does as your desired goal, like as your desired goal, then you will give the dog a treat. So you will just reward him with good actions. And if the dog does not do according to your goal, then you will penalize it, means you will punish the dog. Similarly happens with reinforcement learning. Reinforcement learning trains a model to make decisions by rewarding good actions and penalizing bad ones. So this is it. Just to give, as you gave the example. So next let's go to the next page. Features and labels. I already told you features are basically nothing but the independent variables like the input columns, and labels are the output variables which are the called dependent variable. Now let's come to training and testing data. Now, before doing machine learning to any data set, the work we have to do is split the data set into training and testing. Like we do is 70% training and 30% testing. This is we the partition the data set into training and testing. And likewise, this is the term of what is training and testing data. And now overfitting and underfitting. So what is overfitting? Now, suppose you are studying a chapter, you studied it full.
Hello,
Yes. Hello.
Tell me.
Yes.
Yes,
hello.
tell me. Yes, yes.
Yes.
Hello,
Speak.
speak.
Is everything okay?
Is everything okay? If any doubt, you can chat also.
I think let's
Okay,
continue. If there's anything, any issue, he can chat.
okay, okay. Let's
Let's
continue
continue.
then.
Yes.
Okay. Okay. Now, what is overfitting and underfitting? So, as I was saying, that suppose you're studying a chapter and you solve all the questions of that chapter, you are able to solve everything. But whenever you're going to an exam, you are not able to solve. So this is basically overfitting. This results in poor performance on new unseen data. It does good on training data, but it fails to do in new unseen data, which is the testing data. So this is basically overfitting. Now, what is underfitting? Underfitting is when suppose I'm giving you the same example only. The student studies the chapter, but is not able to do good in back questions also, and also obviously not in the exam also. This is underfitting. With the model does results have like does a poor performance on training and testing data also. I think it is clear now. If any questions, I will take it. Don't worry. So now this is the evaluation model evaluation matrix. So these are basically the four evaluation metrics we see. This is called the confusion matrix. Often you have heard about the term accuracy whenever you do a machine learning. Machine accuracy, you can just guess only the percentage of correct predictions made by model. This is the formula. Now I just see the formula once. I will not because if you see now, it will just seem confusing to you. I will explain you with an example. This I will just give you the full form. TP means true positive, FP means false positive, and FN is false negative. Now, to understand when the recall evaluation matrix is used and when the precision matrix is used, I will give an example. Suppose there is in use case one spam classifier. You are given a mail and you have to predict whether a mail is a spam or not a spam. So suppose there is one scenario, the mail is spam and the model is also saying this is a spam. So it is a very good scenario, no problem in that. Suppose there is a scenario where mail is not a spam, but model is predicting it as spam. Suppose like this is a blunder, like the mail is not a spam, but the model is sending the mail to spam folder. So you will just miss out very important mails. So this is one tremendous blunder. So for this type of problem statements, precision performance is very important. And as you see the precision form performance, I will just go with the formula. It is true positive by true positive plus false positive. So in this precision use case scenario, we need to see that we have to minimize the false positive as much as possible, as much as possible. So if anyone gives this problem statement, I will not only judge you with the accuracy but also the precision performance. So this is one example, and suppose there is another use case, and there the problem statement is to predict whether a person has a diabetes or not. Okay, so let's go to the first scenario. Suppose in actual the person is diabetic, and the model is also saying the person is diabetic. It's a very good scenario, no problem in that. And suppose there is another scenario where the actual person is diabetic, but the model is saying the person is not diabetic. Suppose the person is trusting on the model and he doesn't go to the hospital, doesn't get the checking done, and blunder will happen. I don't know what will happen to the person next day. This will a blunder happen. So in this case type of scenario, what matters is the recall formula, recall precision matrix. Here you say that the formula is true positive divided by true positive plus false negative. So in this formula, we have to minimize the false negative as much as possible. So here false negative is a very important factor we have to see, and here is the false positive. So if this is the scenario, I will uh, judge the performance on the based of recall formula. So this was it. I will go to the next. Now, what is the machine learning workflow? Now, whenever whenever I go to do a machine learning, what the things I do? First is data collection. The first and foremost thing important in any machine learning aspect is to get a data. If you don't get data, you can't do anything. Data is the most important thing because you will apply a model to a data only. So the data collection and the pre-processing. Suppose like whenever we like collect a data, often the data is very raw. Suppose the data can contain many null values, many redundant values, many duplicate values. So we have to pre-process that and make it very free of these errors, like no null values, no no redundant values, no nothing. So we have to do, and there is feature selection and engineering. So what is this? suppose Suppose there are we apply a machine learning algorithm. There are multiple columns, and we see that the two columns are of is much correlated. Like one column is another column is just if you remove one column also, the does not affect the model so much. So in that case, what we can do is just remove that column. We can remove that unnecessary column, and in many cases, the accuracy becomes better after feature selection. So this is one important scenario. This is feature selection engineering and model selection. After we have done all the data collection, pre-processing, feature selection engineering, we apply to the dataset number of models. Like suppose I give you the example for regression. Regression there are many models. For classification there are many models. We apply n number of algorithms and select the model. Now for what we will select the model, first we train and we select the model according the performance metrics. I told you about the performance metrics. According to performance metrics, we just uh, select the model. And about improving the model, model can be improved also. There is a term called hyperparameter tuning. On day 2 or day 3, like we will do a hands-on project. So there we can show you what is the meaning of hyperparameter tuning. So and also I would just like to add one thing. You see this true positive and the true negative. For any, we have to just maximize this true positive and true negative. This thing we have to just maximize it for any like metrics. This one I just gave you an right. And last is the deploying model. You done all the machine learning novels and everything. Now what you need to do is just to showcase to the people. If you don't showcase to the people, then what is the use of it? So for that you need to deploy the model. And deploying the model, there are like if you are starter or beginner, I would like to advise you that you deploy on there are platforms like Streamlit. You can make a note out of it. Streamlit is there, render is there. And suppose if the model is the application is hi-fi, then we need to go to the GCP or AWS or Azure or anything. That comes slightly under the DevOps. We have a DevOps team, so he can explain this all better.
Hello, sir.
Okay, now
Sorry for
next.
the interruption.
Okay,
Could you
please.
please repeat me once again for the which you have tell the platforms?
Sorry.
Could you please repeat once again of the platforms where we have to showcase our project?
Okay, deploying. Okay, in deploying the model, there is platform like Streamlit. You can deploy the model on Streamlit as well. You can just search Streamlit. There is a Streamlit, and you can just go and just give. Yeah, I hope you all know GitHub. You have to just connect it with GitHub, and it will be done. This is a Streamlit platform, and there is also a render. You can just deploy in render also. And if it is as a like hi-fi like machine learning, like it is contains a much criterias, then you need to go to the GCP. For actually in GCP and all those, they we the cost comes to a factor. These are all free, but in GCP there is just a free limit tire. After that, you have to pay. So that is the just one drawback. But other than that, it is all good. So my portion, is there any doubt till that here? You can say me. My part was still here. From the next part, Ayush will speak. If any doubt, you can tell me in any slide. I hope I was able to get you a gist of machine learning. Okay, I guess no doubts. Now I will transfer this to Ayush. Ayush, just go on with the next one. I will stop screen sharing.
Thank you, Rishi Bhaiya. Let's start with the screen share. As it's working, right?
Yes, it's fine.
Now let's get started by discussing the key algorithms that drive machine learning models. Starting with supervised learning, one of the most widely used techniques in machine learning. Supervised learning is like teaching a child with examples. You provide the algorithm with labeled data, which means that each data has an input and a corresponding correct output. The algorithm learns to map inputs to outputs so that it can make predictions on unseen data. Starting with linear regression, the concept lies that linear regression is simple yet powerful algorithm used for predicting a continuous output. It assumes a linear relationship between the input variables and the output. Imagine we are trying to predict the house price based on features like size, location, and age. Linear regression fits a straight line through the data points to minimize the error and best predict the outcome. For instance, predicting how the price of a house changes with its size. The larger the house, the higher of the predicted price based on the trend line. This is the trend line. Picture a scatter plot. So all these are the points in the scatter plot, and all these data points are spread in regards to the dependent variable and independent variables. The goal of linear regression is to find the best fit line that summarizes the relationship between these points. This is the best fit lines, and it summarizes all the relationships so that any dependent variable will have an independent output. Now moving on to decision trees, which are intuitive and work by splitting the data into branches. So this is the decision tree, this part. It's like a flow chart where each decision takes you closer to a final outcome. Let's say you're deciding whether to buy a house. You might ask, is it in my budget? If yes, is it close to my work? If no, then does it have the features I need? Each question creates a branch and the final decision is at the end of the branch. The pros for decision trees are that they are easy to interpret and great for classification tasks, but they can sometimes overfit, meaning that they might poorly perform on new data. Lastly, random forest, which are more advanced approach that builds multiple decision trees and combines their result. It's like consulting multiple experts, expert 1, 2, and 3. There are more in a random forest. So combining their results and averaging their answer for a more reliable prediction. The analogy of random forest is to think of a forest where each of the tree represents a decision tree. Instead of relying on a single tree, the forest aggregates their predictions to make a stronger, more accurate decision. The final output is just the majority voting of all the trees in the forest. Random forest is often used for tasks like fraud detection or customer segmentation due to its robustness and ability to handle noisy data. Noisy data refers to irrelevant, random, or erroneous information in a dataset that does not contribute to meaningful patterns or predictions. It can obscure the tree underlying relationships in a data and negatively affect the performance of machine learning models. So all three decision trees, they finally will make an output, and on the basis of majority voting, we will get the final output in the random forest. I hope it's clear. Moving on to unsupervised learning now. Okay, so here the focus is on finding patterns in data without any labels. So the basic difference is that labels are not there. This approach is widely used for clustering and dimension reduction. Clustering and k-means, where clustering involves grouping of similar data points together. And k-means is a popular clustering algorithm that organizes the data into k number of similarities. So here k is 3, k is just a number. So k amount of clusters are determining the number, and it plays a very major role in the final accuracy of the metrics. Okay, so here for an example, let's take a library without any genre labels. K means might group the books based on frequency, length, or maybe genres too. Okay, so for a library, these three would be the current genre. So I should give you a simplified explanation. Randomly initialize k clusters. So randomly choose a k integer. Assign each data point to the nearest cluster center. So for a cluster center, all the data points are in this cluster. These two clusters are different. Recalculate the cluster centers based on the mean of the points assigned to them, and then repeat these steps until all the cluster centers stabilize. So here it is a stabilized version and it is not stabilized. Well, you can see that these three would be the main clusters, but this is the stabilized version of the k-means. Now moving on to the future trends which are shaping the future of machine learning. Exploring one of the most powerful and transformative areas of artificial intelligence is deep learning. This field is inspired by the human brain and leverages artificial neural networks to process data and make decisions. It's a technology that enables machines to perform complex tasks with remarkable accuracy, making it indispensable in today's AI landscape. Deep learning relies on neural networks, which are computational models loosely modeled after the structure of the brain. These networks consist of multiple layers, often referred to as deep layers, that work together to analyze data and extract meaningful patterns. Each layer of a neural network possesses the input it receives, transforming it into a more refined representation until the final output is produced. This layered structure is what allows deep learning to tackle incredibly complex problems, such as recognizing objects in images, understanding speech, or even generating new content. Deep learning stands out for its ability to process unstructured data like images and audio with unparalleled accuracy. While traditional machine learning requires feature engineering, where humans manually select the important characters of data, deep learning learns these features automatically, making it highly adaptable and efficient. Deep learning is undeniably powerful, but it's not without its challenges. Training deep learning models can be very expensive and requires a lot of data. Additionally, so how a computer makes its decisions is very important, and this remains a challenge in most of the cases. But in essence, deep learning is the engine driving many of the exciting AI advancements today. It's reshaping industries, solving previously untackable problems, and opening doors to new possibilities. Whether it's self driving cars, personal recommendations, or breakthrough in medicine, deep learning is truly transforming our world. Now, transformers, like everyone has heard about ChatGPT, right? So, these neural network architecture are reshaped the way we approach tasks in NLP, natural language processing. These use mechanisms called self attention, which enables the model to understand the relationship between the words in a sentence, regardless of their positions. Transformers excel at capturing relationships, making them incredibly effective at understanding context. Unlike traditional models that process text sequentially, transformers analyze the entire sequence all at once. This parallelization makes them significantly faster and still maintains the accuracy. Transformers are at the heart of many groundbreaking AI applications. Language generations with models like GPT and understanding context with BERT. All other domains of text and speech too. Transformers are shaping the future of AI, and they are here to stay, whether it's enabling smarter chatbots, enhancing creative tools, and driving advance in fields like healthcare and education. Transformers are at the forefront of this transformation. And now AutoML. I guess most of you haven't heard about it, so let me explain it to you. AutoML or automated machine learning. AutoML has redefined how we approach the machine learning process by simplifying and automating many of its complex and time consuming tasks. Traditionally, building a machine learning model requires a deep understanding of data preprocessing, selecting the right algorithm, fine tuning hyperparameters, and ensuring that the model is optimized for performance. These steps often demand a team of skilled data scientists and a lot of time. AutoML changes this by automating much of the pipeline, allowing non experts to harness the power of machine learning. AutoML streamlines the entire process into few automated steps. Data preprocessing is the first. It can automatically clean and prepare data by handling missing values, scaling features, and encoding category variables, all without human intervention. The second is model selection. That is, instead of manually trying out multiple algorithms, AutoML tests the variety of model itself and identifies one of the best ones that it has in its hand. Hyperparameter tuning. Hyperparameters can have a significant impact on the model's performance. You will see that in the third day when you will work with hyperparameters. But these have a very big impact on the model's performance, and also these are very tedious. So AutoML automates this process, finding the best configuration to maximize accuracy and efficiency. In a world where data-driven decisions are becoming the norm, AutoML is leveling the playing field, allowing anyone to with a dataset and a problem to solve to reach to machine learning. So machine learning is not just a buzzword, it's a driving force behind many of the technologies we use today. From improving healthcare to personalizing our entertainment, ML is transforming industries and creating opportunities for innovation. Whether you are a beginner or just starting your journey or someone looking to deepen your understanding, there is so much to explore in this ever evolving field. Thank you so much for being the part of this session. I would love to answer any questions you have. Let's discuss and learn together.
Yes, if anyone has question, Rishik, I guess, raising
Yeah.
hand.
Uh, I was asking what kind of languages do we need to be aware about for learning all of this?
It's Python, Python. And tomorrow
It's
on day two,
Mhm.
yes, please say.
So it's the entire course is based on Python, right?
Machine learning is
Yes,
mostly done
yes.
on Python because
Mention on Python.
Jupyter, if you are aware of it, it's very easy to run all the codes in so that Python is used. And on the second day,
Okay.
we will be giving you an hands-on experience. So if you have Jupyter
And hands on
installed,
as
and if
okay.
not, you should. I would recommend you to install Jupyter beforehand, and you can just carry along with the speakers tomorrow.
Okay. Okay. Thank you so much.
I
Thank
will
you.
say the same. If you want to know like get the real machine learning field, join tomorrow. There we will do hands-on ML. I will not be there. Another speaker will be there. I will be there on day three, so you can join.
Okay. Okay. Thank
And
you
if
so
you
much.
are if you have problem in like installing Jupyter Notebook also, there is also many like you can go in Colab also. You can do there also. You don't have to
Okay.
download anything. You can do directly.
Thank
That
you.
was it. Okay. If any more question, you can say me. If any more question.
Hello, can I speak?
Yeah, sure.
Yes, surely.
So basically, I was asking that will we get any certificate as such after the end of this workshop?
Workshop. I need to ask to Adituda. Is Adituda here? Just a minute.
Yes. What's the question actually? My voice got like the audio got broke.
Are
The
there any
question
certificates
was,
involved? Are there any
yeah.
certificates involved in with the session?
What? Like it's breaking in this end. Can anyone write in the chat box, please?
Okay.
Yes. Actually, everyone is getting a certificate, but the thing is, ki it will take 2 to 3 days after the 3 day session ends. So probably you'll get it in the first or second week of December.
Okay, okay, thank you, thank you.
All right.
Yes. If any more question, I am happy to help. I hope I could get you the
I have
gist
a
of machine
question.
learning. Okay,
Are
tell.
we going? Are we going to make any project tomorrow
Yes,
based on?
it's a project also. And day two, actually, we will have to predict the CO2 emissions of a car.
Hmm,
Pritisha and Ritorshi will take the session on day three.
okay,
And actually, on day two, we will have a regression project. And on day three, we will have a classification project, which is
hmm,
a mental health stroke detection. I will take that session. And on day two,
hmm.
Pritisha will take.
Okay,
So
thank
you
May I
can
know
join.
the
We will.
project?
It will be really insightful. Yes, tell me.
May I know the project of the name?
Sorry.
Uh, can you please tell me about the project
Project,
brief?
okay, project. Okay, project brief. So tomorrow, uh, Pritisha and Ritoshi will take a Pritisha and Ritoshi will take a project on like CO2 emission. You will get to know everything. There is a regression project, so you will get to know on the third day. I will take it. That is about the stroke. If any person has a stroke, uh, so we will classify it, predict it. So I will take that session. So you can
Okay,
join on
and
the tomorrow only. It will
okay,
be happening tomorrow only. It will be really
okay. Thanks for
insightful
the
for all. Okay, thank you.
Guys,
Any
keep your
more?
Jupyter notebook or Google Colab notebook ready so that you can just follow the speaker, because the speaker will be writing the code themselves and you guys can just follow
Yes,
along.
they will
It would
just
be
not
easy for you guys.
reading. Yes, they will just not read out the code. They will just actually do hands-on. So it will be good. I hope that's not an
No,
issue.
Rishik, that would not be
So
an issue because the
that's
speaker
not
would be
an issue.
explaining everything. The speaker will be
Everything. This typical. I highly recommend it if you have just a little bit of coding knowledge. Not that also, our speakers will explain you everything, each and everything. Not a problem. You can learn.
and you
And
guys just
after
can
you
ask anything which you have.
attend these two sessions, I can just conduct a ML hackathon also, and there you can participate and see about and like actually in participant hackathon also you will learn the main things. These are the
can I
theory.
can I expect the date of the hackathon?
It's not really confirmed right now, but yes, we will make sure to have some hackathons too. It's just the first event for this session,
Yes,
and
it's the
we are
first
lacking
session of
the
the GDG only.
yep, and we are lacking the enthusiasm you guys have. So we will surely
Yes.
make some hackathons for you guys too, and we all will be there to help you learn.
And what is the
Yes.
use of the hackathon? Benefits is there? And
So
Sorry.
basically hackathon is just like a competition. You participate and you learn. That's the benefit.
All of the developers you see, they mostly learn from hackathons only. They do mistakes, they do real-time correction, and you learn a lot of things. I myself have learned a lot of things from participating in hackathon. So,
but it's very difficult to build a perfect team for hackathon, right?
Well, if
in
you
I'll
case
tell
of
you what. I'll tell you what. Let's just focus on the 3-day ML event right now. And when the
yes,
yes,
hackathon is actually being conducted in February or March, we'll be releasing a form if anyone wants to build a team or anything. We'll be keeping all of this in mind. And when it is actually being conducted around in February or March, so that the tentative month is around February or March, then we will be helping you guys out in making a team, in giving you ideas, everything. So. Don't worry about that.
yeah,
Let's
that
just
would be
focus on the
better.
yes,
3-day ML session.
okay,
yes,
okay. Thank you, sir.
Right. Mm.
exactly. Any more questions you have, you can ask. Anyone, you can feel free to ask.
So should we call it today?
So, if no questions, you can leave. Come, you can visit tomorrow also. Tomorrow is there also session. There we will do hands-on project. It will be really insightful for you all. You can do that also. I would recommend you to do attend the day 2.
Also, the link is same for tomorrow. Also, an email will be sent to the email IDs like to join the session and all. So everything will be in your email ID, email account, like at 7:20 or 7:15. So I think
Do
that's
we need to
over for
know?
today. No
Rito
need to
Broto.
review.
Actually, we know you don't have to know. Like for basic front end, we often get a basic front end from like many websites. So full web development is not at all required. I just know a little bit of web development and I am able to deploy all the ML models. Just a bit, little bit knowledge. Just no, just big knowledge.
Also, Streamlit is very easy. It's like it gives you all the stuff. You need to write like three, four
Hmm.
lines of code and it gives you everything. So web development is not an issue. Don't worry about it.
That's not basic, not an issue. And nowadays you get every almost all coding ChatGPT. Is there
Yes,
any
there is a
certificate here?
certificate. There is a
The
certificate.
just the just said it.
You will get it
Okay,
from
what
Yes.
what things we
Hmm.
have to bring for tomorrow's session? I mean, Ayush, I think you mentioned Kaggle and Jupyter. And any other?
No,
Kaggle.
two
No,
more.
no. I said
No need
Jupyter
of
or Google
Kaggle.
Colab. Google
Jupyter or
Colab
Google Colab.
and Jupyter. Either one will work.
Either one will work.
Like most
Yes.
of you might not have Jupyter installed, so you can just quickly check out Google Colab.
Just search in center and you'll get it. Okay.
If anyone doesn't have any questions, so I guess I'll give the link to the WhatsApp community if you guys want to join because most of you don't have access to your emails quite a lot of time. So
Hmm,
let me just give the link. It will be easier for you guys.
that would be
Um,
great.
right. Just one second.
Yes, sure.
Yes, Suman Kumari, there is a certificate associated with the workshop. It will be provided to you after you attend all the three. Ayush, you can stop the screen sharing.
All right.
Yeah, actually, sure,
Can you
sure,
share a
absolutely.
review? Yes, surely, surely. I will.
Absolutely. But also, I'll just say ki, yeah, today's session is mostly based on theoretical.
Hmm.
Tomorrow and the day after tomorrow's session will be based on practical applications. So I'll
Yes.
say ki wait for 2 days, attend all the sessions, and then give your review altogether. Um, like, okay, then.
There is now a WhatsApp group, so I guess you guys can ask all these information now there. So we can call it the session,
Right. Uh,
right?
Hmm. And do join tomorrow, guys. It will be a good, insightful experience for you all.
Thank you,
The
everyone.
project we
thank you.
create, we can use in artificial intelligence hackathon. Yes, of course, you can. Okay, okay. About the hackathon, it will be decided later. I just gave you an intro.
Insight. It's just an insight. We are
Yes,
just
just
planning
an
it
insight.
ahead.
Yes, this is the first event of GDG. Many more web development and app development, many more sessions are yet to happen. And about hackathon, we'll discuss it later.
All right, I think it's over for today. Let's end the
Yeah.
meeting then.
Hmm.
All right, let's leave. Thank you so
Thank you
much.
guys for attending this session.
Thank you, sir. Sir,
Not in
can I
GPSC
can we
hackathon, but
share this
another.
PPT?
Yes, definitely, definitely. Yes, sorry.
Okay. Sir, I want PPT, sir. Can you share it?
PPT, yes, you will be provided after the 3 days. I will provide you the PPT after
Okay,
this,
okay.
like 31 to surely.
Thank you, Rishi. Thank you.
Thank you, thank you, thank you, thank you so much.
It was a nice session, and you have gained a good knowledge of ML Foundation. So thank you for
Thank
conducting
you so
this
much.
really digital into ML. So thank you guys, and I appreciate it.
Thank you so much. Means a
Thank you,
lot.
bhai.
Bye bye. Good night.
Bye bye. Good night. Okay. I guess no one is there. We can leave. Yes, you can start.
Okay. First, let me share the screen. Okay. So, hi guys. Good evening. And today we will explore a practical and hands-on project to deepen our understanding of data pre-processing and regression models. And today's speakers will be me, Ritorshi, and here is my LinkedIn account. You can check out my profile. I have done some projects, some internships. You can check out all of this from here, my experiences and my certificates. and my teammate Pritisha Sahu.
Okay, so I am Pritisha Shahu from Technomain Salt Lake GDG team ML, and I'm from third year. And here's my LinkedIn profile. You can see my projects over here. And thank you, Ritoshi. You may continue now.
Okay, thank you, Pritisha. My screen is visible, right? Yes, it is.
Yes, it's visible.
Yes, yes, yes.
So let's start. So today we are going to do a hands-on project. But before we delve into the project, let's start from the basics. First, we have to understand the problem statement, right? So let's do that first. The problem statement is to predict the CO2 emissions of vehicles based on various features. These features, suppose we have the data set, right? We have the data set, and these features are the columns such as engine size, fuel consumption, vehicle specifications. Okay, and somehow my screen got minimized. Okay, and about the data set, just the thing that I said. These are these make, model, vehicle class, engine size. These are the columns, and the output is already we already have the actual output with us, and we have to predict the output by linear regression in this hands-on project. Now, before we do any implementation of model, we have to do the pre-processing, which is very important because pre-processing is actually boring, but this is the most important part of machine learning. As without it, our our prediction, the prediction that we will do will actually not come close to the actual value, because in under pre-processing we are going to check missing values, duplicates, data types. We are going to convert all the objects and strings to numbers. And we are going to convert it to numbers because machine learning models can only read the numbers, right? They cannot read the text values. So we are going to convert everything into integers, and then we are going to do feature selection based on correlation. We are also going to replace the missing and null values. Suppose our data set has some missing values somewhere in some of the columns. In some of the columns, some values are missing. So we have to replace those missing values and null values with the mean of of that column, right? I'll say more about this later on, but I'm just giving you all an overview. So, and ultimately, lastly, we have to do the outlier detection. What is an outlier? Outlier is basically the values which are largely varying from the of I mean some value which is largely varying from the average value of that column. So after the whole thing is done, then we will do the implementation of model, because then we have pre-processed our data and it is ready for the model implementation. Now let's start. Let's start with, and here under we have made a directory and gdg folder. We have the co2.csv. This is the csv file. This is the csv file that we will be working on. Okay. I know you will not understand most things here, but these are the names of the columns: make, model, vehicle, and these are the values. And let's start now. Any query till now? Anyone? Okay. So let's start the coding part. First, we are going to import NumPy as NP. Now, NumPy is a Python library which is mainly used for numerical computing. It provides support for arrays, matrices, and other mathematical operations. Okay, and we are going to call it as NP because we do not want to write the whole NumPy name every time, so we are just shortening it to NP. Next, we are going to import Pandas. Pandas is a library which is used for data manipulation and analysis. It is mainly used to make data frames, and data frames. You can understand data frames. It is a type of two-dimensional array, right? It looks like a table basically. Okay. Then we are going to import matplotlib. matplotlib.pyplot as plt. Matplotlib, it is mainly used for data visualization. Like we are going to visualize some heat maps, not heat maps, not Matplotlib will not help in heat map. We are going to visualize some histograms, and those things will be done by Matplotlib. And after that, we are going to import Seaborn. Now, sorry, Seaborn. Seaborn is actually built on top of Matplotlib, and it provides even more advanced visualizations. And we are going to see a heat map using Seaborn today. Okay. And lastly, we have Scikit-Learn. Okay. Uh, Scikit-Learn, it is actually a library for machine learning. It provides tools for pre-processing and training and evaluating models. And from the scikit-learn model, we are importing train test split. This function, this function basically it splits the data into training and testing sets. For example, we have a data and it is 100%. Okay, like we have a data and we have the 100% data. We are going to split it like into 80 and 20%. Mainly we do it, the 80% or the majority section is required for training, the training part, and the lesser part, the rest of the part it is kept for the testing part. So if we split it into 80 and 20, then the training part goes to the 80% and the testing part is for the 20%. We train our model on the 80% training data, and the 20% is later required for validation. Now we are again going to use scikit-learn. Scikit-learn is actually a very good module. It has a lot of things. We are also going to import linear regression model and logistic regression from here. Import level encoder, comma, standard scaler. Now I'll tell more about this in later part, but I'll just tell you, level encoder, it basically converts the categorical data into numerical values, and standard scaler, it scales our data. What it does is that it subtracts the mean and puts the data into unit variance. Okay, and here I guess we are done with it right now. Let's execute it. See, here it is showing 1, which means that our cell has already been executed. If it is showing nothing here, which means that our cell has not been executed here, or something reddish over here, which means some error has come. Okay, so let's start now. First, what we are going to do, we are going to load our CSV file, the co2.csv file, into our variable data, right?
Can you please show me
So
how you executed that import statement?
what we did,
How you executed the import statement? I mean, you did a process in between.
how I executed, I just pressed enter. I mean, either press enter or here run code. And especially, you don't even have to write this, since we are writing in i.ipynb file. You can just press shift plus enter, and the cell gets executed.
Okay.
The same goes with, if you are doing it in Jupyter, it will happen the same way, or Google Colab even.
Okay.
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 Okay. So can I proceed?
Yes, please.
Okay. So data pd. Guys, first I'll write the code and then I'll explain. Okay, I cannot do both the things simultaneously. Read underscore CSV CO2 dot CSV. Okay. So read underscore CSV. What this function is doing is it is loading the data set that we have over here into this variable data. And what is helping us doing it? Pandas. I've told you, right? I've told you about this when I was importing these files one by one. Now see, now it is written 2, which means that this cell has been, it will go on like this, 1 2 3 4, like this cell has been executed without any, and there is a tick, means there is no error. Okay, now we are going to do is data dot head. Now data dot head, what this function does is that it gives you an overview of the data set. Let me show you how. When I okay, let's just execute it for once. This is the overview of the data set. It is now, right now it is showing only 5 rows. 0 to 4 means 5 rows, and these are all the column names that our data set has, and these are the column names, and these are the data that we have. Now for example, if we want to see more data, maybe 10 10 rows, we can just write 10, execute it, and now see, we have 0 to 9, which means 10 rows has been printed over here. Okay, we can specify any number. I mean, to any extent, to what extent you want to see, you can just write it over here. So for now I'm just keeping it like this. And also just how many, the number of times you execute the cell, the number also increases here. This is not needed, although I'm just saying it anyway. Now comes the part data dot info. The info function, what it does is that it provides us a summary. It provides us with a summary of the data frame, including column names, their data types, whether we have any null count for each column. The purpose is to identify any potential issues, whether our data set has any potential issues like missing data or incorrect data. You remember, right? When I was explaining this, I was saying that we are going to check for missing values and null values. So now we are doing exactly that. As I execute this cell, we can already see that the data type is written over here. This is make is object, model is object. This is float and integer. Cylinders, the all the values of cylinders are in integer. These are object, means these are their values are in strings. Okay, and further, we for further confirmation, we can just write another statement is null. Now I haven't executed it yet. What it does, when I write data dot is null, it returns a data frame of the same shape as data, where each cell is true if the value is null or missing, otherwise false. If the value is true, then it returns. If the value is null, then it returns true. Otherwise, it returns false. Okay. Now I'm going to write sum over here. What it does is that it sums up the true values columns by column wise to get the total number of missing values in each column, which means that we are going to get an output with all the column names here and all the missing values over here. Okay, let's execute it and see. Now all the column names has been printed over here, and we can see that here it is written 0000 and so on, which means that we have no missing values in our data set. If we had some missing values, the number would have been different, like 2 or 3 or 100 or 200, depending on the number of missing values. But since we have no missing values or null values in any of the columns, so it is showing us 0, which means that our data set is perfectly fine, and we do not need to do anything further here. Okay, but suppose the data set you are working on is having some missing values or null values, and you need to clean it. Then there are two ways you can do it. Number one is that you can just drop the column. I mean, that's a harsher way, a rough way, but you can drop the column if it is not that important. I mean, some columns have, maybe the column, most of the values in that column are missing. So of course, in the end, you can just remove the column. Or maybe just a few of the values are missing, but the rest of the column is just fine. In that case, what you can do is you can use this function data.fill na. I will not be executing this because our dataset is doing fine. But what this function will do is that it will take the column, it will take the mean, it will take, I mean, this is only five values, it will take the whole datasets, this column's whole value, the whole column, and then it is going to find out the mean, and then it is going to put that mean into those missing values. Got it?
Yeah, got it.
We
It's
are all
same.
on the same page, right?
Sorry for the interruption. Uh,
Did you understand?
yes, sir. It mainly uses the whichever the column is take a main or more. Is take a main or more video. Yeah, three things.
Sorry, but your voice is cutting out. Pritisha, can you just look into it?
Uh, Fill null value is it will be take only medium main mode.
No, not medium mean mode. It will take the mean value, and it will take the mean of the column, and then it will replace the missing values with the mean of, with the mean. Okay,
Main of the numbers.
the mean of the column will be put in those missing values, whatever
Okay.
missing values we will have in our data set. In our data set we have none, so we are not going to use this function. But
So
when you are doing it,
we cannot take a median or more. Why we are taking median?
see, mean is basically the average, right? Mean is basically the average. If you have to see, if your data set is important, right? If your column is important enough, mean means the average of the column. So as we are replacing the missing values with the mean of the data, with the mean of the column, this is giving us an average, and the output we are going to get ultimately will be very close to the actual output, the predicted output. Our ultimate intention is to match the values of predicted output and actual output. It will not match it, we have to get the accuracy as much as possible. So in order to do that, we have to replace the missing values with the average values, right? Average values of that column, the average value we
Okay,
get.
okay, I
Okay.
understood. But my one more question is, uh, take a random column, random row in that column. It will have a very huge number of similar rows columns from that. Suppose we have 10 rows in that particular column. We have each row 10 to 8 numbers only, and another special row have 50, 60 numbers. So it is the occurrence of the outlier also, no, sir? So in that situation, main will work or not?
But your voice is cutting out, man. Wait. Can you just type it out?
Yeah. Suppose
I'm asking you to type it out in the chat.
oh,
I got your question. See, actually, what we do is, suppose there are like in a column, there is just there is no just two or three or five, just very minimal number of null values. From so in that case, we can just remove that just column only. But suppose there is like many null values. In that scenario, we include the mean values of the whole
but
column.
at the I understand earlier also. So my question is, if a row has a huge number
Okay.
related to the numbers. Suppose we have 10 rows, the right, sir.
Outlier. He's
So
talking about outlier.
talking about outlier. So the one of the row number is 50, 60, and another rows have below 10 only. So it causes an outlier, no, sir. It causes an outlier.
Yes, you are correct. Yes, yes.
So
Yes,
in that
whenever there is,
situation,
huh, huh.
the main
tell.
will work, or we have to put median or
What will work?
main will work in the time.
In that case, we would at first remove the outliers and then we would replace it with the mean.
Okay,
Hmm.
Yes.
thank you. Thank you for clarifying.
See, if what you're saying, I got it. If a value is too big, right, in the middle of the column, and it will of course it will vary with the others, and it might change the mean, right? So, what in that case, if something like that happens, we can remove the outlier totally, and then we get the mean of the column, and then we replace the missing values with the mean. Okay.
Okay,
Okay. Let's start it again. Sum is done. Now what we are going to do is data dot describe. See, what you are saying about this describe this function, it gives us a statistical summary of all the numerical columns. It gives us a count, the number of the number of values in that column, the mean of that column, the standard deviation, minimum, maximum, and the quartile values. 25% of the whole column, 50% and 75%. And it is being done for all the columns over here. Okay. Next, what we are going to do, we are going to visualize something. Data.hist fig size is equal to 15, comma 10 plt dot show. What this hist function is doing, it will be creating a histogram of all the columns that we have as features, and the fig size, it is basically it is adjusting the size of the output figure, and plt dot show, it is to print, I mean to show the visualization. Let's execute this cell. Yes, as you can see, we have got the all the histograms of for all the columns here, and let's see it. We have the x-axis here and the y-axis here. X-axis shows us the number of bins, or in easier terms, we can say the range of values in that column. In engine size, the range of values in that column, and so for example, we are taking a range of 0 to 2. So in this range, how many data points are falling into, or you can say the frequency of the data points, that is what is written, that is what is given in the y-axis. Okay, it's all right, right? Okay, and the same is being done for cylinders. This column, fuel consumption, CO2 emission. This is the our actual output, by the way. Now what we are going to do is we are going to do some level encoding. I have told you, I told you about this earlier in the beginning of the session when I was importing this here, label encoder and standard scaler. Now let's dive deeper into it. Okay, label is equal to label encoder. I called the function here, and what this function actually does is that it converts the categorical. Okay, before doing it, now I can let's do one more thing. For doing it, I'm going to show you the head one more time. I'm doing it so that I can actually show you how it converts the all the categorical data like AS5, Z, all these values into numerical values. Okay, so let's write the code first. Label is equal to Level encoder. It. I'm just taking an example just to make you understand. For example, we have A over here and we have B over here. What it does is that it converts it into something like, wait, just 1 second, 0 comma 1. I mean, it assigns a number to the text input we have over here. Okay, now what we are going to, let's write it first. Data score make is equal to level dot fit transform data make. Now you can see that we have used a function called label.fitTransform. What it is actually doing is it fits the encoder to the column and transforms it into numerical values. It is fitting the encoder to this column, it is this encoder to this column make over here, and transforming all the values which are under this column into numerical values. And we will be doing this for all the columns. Okay, let's try it out. Now let's copy it first. Copy. Just I will now just change the column names. Model, vehicle class, transmission, fuel type. Okay. Now let's execute this cell. Now that it has been executed, let's try data.head once again. Data.head. See, all the values which are under make has been converted to numerical values. Here we had fuel type had all Z written over here. Now it is written 4 over here. A is 5, A now transmission. All the values which were under transmission column has been changed into numerical values. This is what I was saying. When I was explaining this PPT over here, you can see I have written it converts in the second point, it converts all the object and strings to numbers. That's what we just did over here. Okay. So that's what we have in level encoding. Now we are going to do some standard scaling. SC is equal to standard scaler, and before I do further, I have to actually copy the columns. So I am executing data.columns. It will give me the names of all the columns over here, and I have called the function standard scaler into this variable SC. It gave me all the columns which I'll need to scale. I'll explain what standard scaler means and everything. I'll explain. Okay. I copied it. Now columns to scale, and I'm pasting it over here. Okay. Oh, now data.sc. I'm just tweaked the name. Data, I was using data till now, and now data underscore sc is equal to sc dot. I'm going to use this fit transform function once again, and then data columns to scale, and then I'm going to write data underscore sc underscore df is equal to pd dot data frame, then data underscore sc columns is equal to columns to scale. Okay. Now I have said a lot, written a lot of things over here. Let's see them one by one. Okay. So first we wrote columns to scale, where I just copied all the columns that we have, right? This list basically specifies which columns will be scaled using the standard scalar function. What do we mean by scaling? I'll get to that, but let's explain the code first. Okay. Then what I do is I use the function fit underscore transform. It fits the scalar data, the data that has been scaled, and it fits them into the data underscore sc and applies the transformation. And lastly, after we have the scale data, we use pandas to convert the scale data back into a pandas data frame, because after all we need it into a tabular form, right? We need it into a tabular form, so we take the help of pandas and convert the scale data back into a tabular format or data frame, and then we do the math so that we can do the mathematical manipulation and analysis on it. And we can check this out how our data looks like right now. Data underscore sc underscore df dot head. Yeah, now negative values coming over here is totally fine. It always happens when you scale the data. Okay, now what is actually happening over here? Let's understand that. I have written some things here. Standard scalar, what it basic the formula is that the data, we take the data point, we subtract the mean, and then divide it by the standard deviation. Standard deviation formula is also given over here. It basically what it does is that it scales the numerical data so that each feature has a mean of 0. We are subtracting the mean here, so mean becomes 0, and we get a standard deviation of 1. And why? When lastly, you must ask this to me that first of all we did the numerical transformation. It's fine, right? We have to do it for for the betterment, because machine learning models can only read numerical values, so we converted uh, all the values into numerical data. And now, but why are we doing standard scaling, right? So we are doing it because it prevents features with larger scales from dominating the model. We are basically balancing the model, right? We are balancing the scale, and it also improves the model performance and speed. So now that we will be working on the scale data, the model performance and speed will work even better than before. Okay. And with this we are done with data pre-processing. Now I'll show you one last thing, one little thing, just correlation. Okay, data underscore sc dot, or this is not needed though. ठीक है. And oh shit, sorry, data underscore sc underscore df. This is giving me a table. I'll explain it even better with the visualization. let's just see the visualization, then I'll come back to the table. Okay, now let's write it. Now for the visualization, we are going to take the help of the Seaborn library, which we imported at the beginning, and we are going to call it with the name SNS dot heat map. Then we are also going to write data underscore sc underscore df dot core correlation function, and not is equal to true. And the we are going to the we are going to get a heat map, right? So I'm just going to give it a color is equal to greens. Now when we execute it, you see we have got a visualization, a correlation matrix like this. All the diagonals are, first of all, let's just see what correlation means. Correlation means it basically tests the strength of the linear relation between variables. What are the variables we have over here? The columns. The columns are our variables, and we are going to test the strength, basically the linear relation of one column with another. Okay, if we have +1, if we get a value of +1 here, you can see that we do have a scale 1 to 0, and then here negative values start coming. So if we get a perfect +1, then we have perfect positive correlation. If we have -1, then we have perfect negative correlation, and if we have 0, then means no correlation. Now you must be asking that what is the need on, or what it is actually showing. So for example, let's see the data for once. Here we are the diagonal is 1 because this is the same fuel consumption combination, that is why the diagonal is 1. Here you can see that 0.99, it is very close to 1, and that is why it is in the darker range. Here we can see that fuel consumption combination 0.99 is having almost perfect positive correlation with fuel consumption per city, which means having a perfect correlation, or having a almost positive correlation, means that if one variable increases, the other one will increase too. Okay, so if this variable increases, this one will increase too. And if we have a negative correlation, maybe something like in here, like for example there's 0 minus 0.93, it is in negative, right? And it is very close to 1. No, not very close to 1. Let's take something else. 93. Okay, no, this is the largest value which we are getting. 0 minus 0.93. So this is very close to -1. And if we see, if one value in that case, if one value in this column increases, then the other column, the values in the other columns decreases, and vice versa. This is how the correlation works. Okay, and if we have zero, like if we have zero, like there is nothing, then there is no correlation between the variables, and we have no linear relationship. This is it. Okay, I hope I made it as much clear as I could. Now the model implementation part and the deployment part will be done by my teammate Pritisha, you may go on.
Okay. Uh, so I will be heading with the model evaluation and model building. So before that, I would like to brief you guys about some basic terminologies and concepts before we move on to the code. Okay. So before we start building the model, we need to know one thing, that is what are the dependent and independent variables. Okay, so by independent variables I basically mean the input features or the variables that will be used by the model to predict the outcome, right? And for the dependent variables, it is simply the outcome column, the value that the model will predict. Okay, so knowing this, now we can move on to linear regression and logistic regression. You can see both the regression models work on supervised machine learning algorithms. That is, they work with labeled data. Okay. But what is the difference then? The difference is that for linear regression, the dependent variable column, that is the outcome column, we are predicting continuous output values for the dependent column. Okay. That is, we are finding continuous numerical outputs for it. Whereas for the logistic regression model, what we are doing is we are finding probabilistic value. Okay, for some binary outcome, like it can be true or false, 0 or 1. Okay, it will say the probability of which class it can belong to. Okay, and now in linear regression, if I say what it does is it tries to fit the best fit line along the where we can plot the independent variables on the x-axis and dependent variables on the y-axis. And the main purpose is to reduce the error between the actual data points and the predicted values. That is the straight line that you can see. This is the prediction. Okay, so we would try to fit the straight line such that the errors would be minimized as much as possible. Okay, but what happens in linear logistic regression is that we are using a sigmoid activation function. If you see that, see, I think you most of you would be aware of this function. So this is the
Sorry to
sigmoid.
interrupt.
Okay.
Screen is not being shared, Pritisha. I guess.
Sorry, sorry. I missed out on that. Is it visible now?
Yes.
Okay,
Go
I'm
on, go
so
on.
sorry. Okay, so let me repeat it again once. So for linear regression, what we do is we try to fit a straight line, the best fit line, such that the error between the actual data points and the predicted values by our machine learning model is reduced. Okay, so we are basically aiming to find the best fit lines, and we plot the independent variables along the x-axis and the dependent variables along y-axis. By dependent variables, I mean the outcome, and independent variables are nothing but the input features. I think it's clear now. Is there any query? Okay. So now coming on to logistic regression, what logistic regression does is that it predicts the probability of a binary outcome. Now, by this, what do I mean? It would predict how much possibility it has to be in one class or the other one. That is the reason it is often used for binary classification tasks like spam ham detection, etc. And yes, so what happens is that in logistic regression, we use the sigmoid activation function. Maybe I think you guys are aware of this function. It is 1 upon 1 plus e to the power minus x. What it does is it brings the value within a range of 0 and 1. So ultimately, it makes the value a probabilistic value. So for the sigmoid function, we get a graph like this. And this model is very useful when we are doing something like binary classification or something like that. It is also widely used in healthcare fields, marketing, finance, etc. And now, before we start with the code, I would also like to give you a brief overview about the evaluation metrics. Like, how would you understand which model performs better? Like, generally, when we are working with any machine learning problem, what we do is we test it upon various models, and the one which performs the best, we try to implement that model, right? So, for that, how would you understand for that for multiple models? Generally, for regression, we have these three metrics: the R2 score, the mean squared error, and the mean absolute error. Fine. And the model that will have a higher R2 score is generally considered to be better. Whereas it is opposite for the mean squared error and mean absolute error. Fine. So the models with lower mean absolute error and lower mean squared error are better. And also, there is a point written C. It is not robust to outliers. Mean squared error is not robust to outliers, whereas mean absolute error is robust to outliers. Now, I would like to explain this point, and for that, let me show you something. Okay, so as you saw the formula of mean squared error and mean absolute error. Okay, for that, let's suppose we have a y actual value and let's initialize them with some random values. This is the actual outcome, okay, that is present in our data. And y prediction is what? It is the outcome that is predicted by the machine learning model that we implemented. Fine. So the MAC says the formula is summation of the squares of the residuals by n. Now, what do you mean by the residuals? Residuals
Pratisha,
are
just
the
zoom a little bit so that.
okay, okay,
Okay.
yes. Is it visible now?
Yes, I guess. Yes, yes.
Okay. So,
Someone asked for it, so
okay,
yes.
okay, no problem. Uh, so, what do you mean by residual values is the difference between the actual and the predicted values. Okay. So after that, if you see the formula, where did it go? So here you can see the mean squared error formula is the residual values. See, this is the residual value. Actual and predicted values, their difference is taken and they are summed up and then divided by the total number of data points that we have, right? Whereas for mean absolute value, see, we are taking the mod value of the residuals. Okay, so how is this going to affect the outliers? See, if we have outlier values, then the residual value will be larger, right? So when it is squared up, then the value would actually increase a lot. As a result, what will happen is that the model's performance will be affected. As a result, mean squared error is not very robust to outliers. But for mean absolute errors, the value will not be that high, so we can neglect that and hence it is robust to outliers. So with this, we have done some basic theory and now we can jump on to coding. Before that, do you have any questions?
Yeah, I have.
Yes, please, just wait a second. Yes.
Uh, Ma'am, please tell me what is actual value and what is predicted. Predicted value means that we have it will comes under the error value, right? Asked error.
Sorry, your voice is cracking. Can you be a bit louder?
Hello.
Yes, yes.
What is actual value, ma'am?
Okay, for that, let me show you the data set once. You'll be having a clearer idea with that. Okay. If you see the data set, it is not well formatted, but if I open it in Excel, it will be. Wait, let me show it to you in Excel only. Next. Yes. Okay, so here you can see, is it visible?
Yes, yes.
Hmm.
Perfect.
So here can you see this column CO2 emissions gram per kilometer? See, here
Yeah.
are all these values that are already given. What is a supervised machine learning's aim basically? It works on labeled data. That means these are the correct outputs that the model should predict. But due to the algorithm, the output that the model predicts is considered as Y prediction, and the actual values that I was talking about are these values. Okay, these are the values.
Okay.
Okay, is it clear now?
Yeah, it's clear. And
Yeah,
one
thank
more
you.
thing,
Hmm.
what we are what are the features and what are the dependent?
Okay, let me repeat that. So yeah, see this data set. Okay, here what are we actually predicting? We are trying to find out what is the CO2 emission based on these features, right? We we will find out the CO2 emissions based on all these features. So the
Okay.
features that we are using to find the output, all these features, okay, all these are nothing but the independent variables.
Yeah.
And it is the dependent variable because its
Yes.
value depends on all these features, right?
Yeah.
So that was what I was saying. Now I think with the visualization it would be more clear. Okay, any more doubts?
Basically, we have to take an actual value on dependent variable.
Yes, yes, yes.
It doesn't work on independent variables.
What?
It doesn't work on independent variables. Actually, I'm
Sorry, I
asking
could
about
not
actual.
understand you.
Can you rephrase your question?
Hello.
Huh?
It actual value works on dependent variables only, and it doesn't work on independent variables.
See, it is not like that. What I basically meant to say is that these are the values that I already have. So these are the actual values. Fine. And the predicted values are the values that the model will take in the input, apply some algorithms on it, and it would try to predict a value for the CO2 emissions, right? So that is my predicted value.
Okay.
Do you still have a doubt?
No.
Okay. So shall we start with the coding part?
Yes, ma'am.
Okay, thank you. Okay, so I have already copied the same code. Now let's do the rest of the part. So let's first differentiate the independent variables and the dependent variables. Fine. So let's take the independent variables into x. Okay. X is equal to data dot drop. Let me write the line, then I would explain that to you as well. Okay. So So what I said is, like, do you remember the input columns? What are the input columns? All these are the input columns, right? All this except the CO2 emissions. So if I just drop this whole column, that is remove this whole column, then I would have only the input features or the independent variables, right? So that is what I am doing. And by axis 1, I mean that what we are dropping, it is a column. Like if it was axis equal to 0, then it would assume that this is a row present. But for us, it is a column, so we would specify it with 1. Fine. And now y. Y is the dependent variable. So what is the dependent variable? This column only, because this is the one which we are trying to predict. So this is data of this column. I hope it's clear. Is there any doubt? Okay. Okay, so we have segregated the dependent and independent portions. Now what we will be doing is we would split the data into training and testing data. X train, X test, Y.
Sorry for the interruption. Please
Yes.
zoom little bit.
Acha, okay, okay. Is this fine now?
Yeah.
Okay. Y train and Y test. Train X, Y, test size. Let's take the test size as 0.3 and random state equal to any value 42, let's suppose. Now what do I mean by all of these things? Like, you remember, right? X is the independent variable and y is the dependent variable. Now what we are basically doing is we are trying to split the data set into two halves. The majority portion is for the training and the rest is for testing purpose. And here you can see this argument, test size equal to 0.3. What this does is that it splits the data such that 70% is taken for training and 30% is there for testing. Fine. So with that, what does xtrain mean? Xtrain is the independent variables from the testing set, a training set. That is the input columns from the training set. We are trying to mean that. Okay, input columns. And x test is the input columns from the testing set. And similarly, y train is the output of the training set, and y test is the output from the testing set. I hope that was clear. And yes, this parameter, random state. Why did I mention this? This is mentioned because suppose there are multiple developers working on a same code, right? So what happens is when they are splitting the train test data, when you are running this notebook, different portions will be selected for different users. Like for you, some row might be in the training data, and for somebody else, it will be in the testing data. So this will result into a mismatch into the results that you obtain. So generally, what we do is we try to maintain a specific random state already beforehand so that all of the developers who are running this notebook get the same results. Fine. And it is easier to work then. So let's run this. Yes, it is executed. After this, we need to import the models first. So let's import, from sklearn dot linear model import. We are going to import two models. Okay, linear regression and logistic regression. Fine. After this, let's initialize both the models to some variables. For the time being, let me initialize the linear regression model with this variable name model. Okay, linear regression, and let's initialize another variable, maybe model 1 will do, with logistic regression. Yes. Yes, so we have our models initialized. Now what do we need to do? We need to train these models. We need to train these models based on the training data that we segregated. Now in the training data, you remember that we have our inputs and our outputs, right? So we would pass that to the models and train them. And for training, we would use a function called fit. Model.fit x train, like this is the input and this is the output. Yes, so see, our model is ready, and similar manner we would also make the logistic regression model. Model1 dot fit x train comma y train. Okay, it's taking some time. What happened? Oh, okay, it's fine. The model is ready. Okay, so now, did you guys understand how the training data was fit into the model? Like the input and their corresponding outputs are provided to the model, and the model will try to fit the best fit line such that the errors are reduced. Okay, and for logistic regression model, it would try to use the sigmoid activation function. Now, let's store the predictions that the model made into some variable. Like for linear regression, let's store it into a variable called ypred, means the predictions. Okay, so we used model for our linear regression model. So model dot predict. What are we predicting upon? Like what is the thing that we are predicting on? We have the test data, right? The test data, for each of the input of text data, we want a corresponding output. So we pass the input for test data. Okay, so let's do this. Okay, so it is done. Now ypred1. Let's initialize this variable as ypred1, which will store the predictions for the logistic regression model. So for logistic regression model, we use this name model1. So model1 dot predict. Again, the inputs from the test data. Okay, test. So it is done too. Now what we have to do is see this data set we have, right? So which model would perform better on this data set? We need to evaluate that, and for that we have some evaluation metrics. So let's import those metrics from sklearn dot metrics import R2 score. Remember I told you about this, and mean absolute error and mean squared error. Okay, so the imports are done. Now let's find out the R2 score for linear regression and then the R2 score for logistic regression, and then we would compare them. Okay, so let's consider it as R2. R2 is equal to R2 score, R2 score of what are we now comparing? We are comparing the our actual output and the output that has been predicted by our model. So what was our model's prediction? It was ypred, right? And what was our actual output? Actual output, if you remember, it was y test, right? No. Just a second. Yes, it is ypred, y test, sorry, because these are the corresponding outputs from the test data. Sorry, ypred and y test. Similar way, here only we can calculate the R2 score for our logistic regression model. For logistic regression model also we are using R2 score, and we will pass the predicted values. So where are the predicted values stored? They were, if you remember, they are stored in the ypred1 variable. See, it is coming from model 1, which is logistic regression model. Fine. So we would pass ypred1 and y test, and now let's print it. Print R2 score for linear regression. It is R2. Now for logistic regression also, we will print it in the similar manner. R2 score for logistic regression is R21. Okay, so let's see what came. Okay, there's some mistake. The logistic regression R2 score is coming negative, but it should not come negative. I think we made some mistake over there. Let's check the code. Extreme X test. Y transfer. This is mean. Y prediction and Y test. Okay. I think I got what was the mistake. I should have used the scale data. Sorry, scale df. Yes, this was the reason we were getting the error. Okay. It should work fine now. Okay, so now you can see the R2 score for linear regression came out to be 0.9055 something, whereas the R2 score for logistic regression came as 0.889 something. Okay, and as I said earlier, if you remember in the PPT, the model that gives a higher R2 score is considered to be a better model. Fine. So here, the linear regression would be considered a better model. But let us evaluate it on basis of mean squared error and absolute error as well. So let's find out. First, mean absolute error. Let's find it for the linear model. So mean absolute error, and we pass in the same things because we are always comparing the predictions with the actual outputs, right? So this is the mean absolute error for linear regression, whereas for logistic regression, we can name it as MAE1, and mean absolute error of y pred and y test. Okay, this should be y pred 1 because we have the predictions of the logistic regression model stored in this variable y prediction 1. Fine. And now let's print it. Print mean absolute error for linear regression. It comes out to be MAE. Now for logistic regression model, the mean absolute error for logistic regression, it comes out to be MAE 1. So let's see what are the values that it gives. Okay, so see, here for linear regression, we get something around 11, whereas for logistic regression, we get it something around 12.9. So, which one has a lower mean absolute error? This one definitely. And as I said in the PPT also earlier, the lower mean absolute value model will be a better model. So here also linear regression wins. Now just let's test it up for mean squared error. So MAC equal to mean squared error. Same things again, y pred, comma y test. Then MAC1 gives mean squared error for y pred and y pred 1, sorry, and y test, because we have the predictions for logistic regression model in this variable. Right. So now let's print them. Print mean squared error for linear regression. This is MSE, and print mean squared error for logistic regression, and it will be MSE1. So now let's execute this cell and see. Here also we get a lower MSE value for the linear regression. So ultimately we know that the linear regression model works well with the data set, right? Now what we will be doing is we will be creating a user interface to take in the inputs and predict the outputs. So for that we need to save our model. So how do we save that? For saving our model, we need to import a library called pickle. Import pickle as pkl, and it is just an alias name, a short name. Okay, so now we write it as with open model.pkl. It is just nothing but the name with which we will be saving our model with, and we will be opening this model in write binary mode because we are going to write the model, right? So we are opening it in the write binary mode. And if you're familiar with the file operations in Python, you must be knowing that these operations are performed with a file object. So we are initializing that file object. Fine. After that, what do we do is pickle dot dump model with the help of the file object that we created. So let's execute this, and now here you can see we have a model.pkl file, and this is only the file which would be used as the model to predict our outputs. Fine. Now, with this, we are done with the notebook, the model training and evaluation. Now, what I'll be showing is how to create a front end for it. Okay, so this will be an optional part. If you do not have VS Code installed, probably you would find some problems, but later you can do it. It's quite easy. Till now, do you have any doubts?
Yeah, hi. Please explain me once more again the pickle about pickle.
What?
About right now you have installed certain library. Please
Yes.
explain me once again.
Okay, this library is used for file operations. Okay, what we are doing is we are writing this model into this file called model.pkl, right? For this, pickle library helps us with it. Okay, and if you just go through the basics of file operations with Python, you would see that we perform this file operations with a object, file object. So this file acts like that here, and we are opening this in the write mode because we will be writing the model into it. So this is what I meant. Is it clear?
Okay, thank you.
Okay, any more errors? Shall I continue now? Okay, let's continue. Okay, now we will make a new file, app.py. You can name it anything. I am just naming it as app.py. Here we will need some imports. Let's import them. Import pickle as pkl, because the a model that we made, we also need to read that model, right? So we are importing pickle, and then import numpy as np, import pickle, import numpy, and yes, for the front end we will be using this streamlit. If you do not have this installed, you can just install it by typing pip install streamlit. Okay, streamlit as st. Okay, now in our application we would always like to start with a heading, right? So for that, Streamlit provides us with a lot of components. You can just go and browse through their documentation as well. There are various other components as well. We will be discussing some over here. So let's write st.write CO2 emission emission prediction. Okay, this is nothing, just the title of our, sorry, right now it's title title. It is the title of our application. Okay, now what we will be doing is we will load the model. Okay, so for that we use with open model.pkl in the read binary form, and let's initialize the file object again. and we would load the model into some variable. So I am using model as the variable. So model is equal to pickle dot load file. Okay, the file object will bring the model. Okay, there's a spelling mistake. Pickle. This pickle dot load will bring the file and store it inside the model. Okay. After that, we will have to make some input boxes to take the inputs. Okay. For that, let's first see what the inputs were. I think we have, oh wait, we have the CSV also. So these are the input columns, like make, model, vehicle class, engine size. So for each of the input, we need to make an input box for this. So let's make an input box. Here, let's make a variable make. This make variable will store the input that we as a user will input. So for that we use st.number input make. Okay. So this make here in the string represents the placeholder value. Basically that like the input box will show this value to the users initially, and you can also assign some arguments like minimum value, that is somebody should not use a value lesser than this. We can initialize it with 1, and step also we can give, like it will give you a plus sign and minus sign to increment and decrement the values. You will see when the UI is ready. Wait. Okay, so similar way we will have to do it for all the columns, and I know we are running out of time, so I came prepared with these values as well. I would just copy these values. This is just the same, just the value, the column names get changed. Fine. So let's do copy it here. Okay. So this would make all the input boxes that we require. Now let's make a button upon clicking on which we can pass the input values to the model, and the model will give us some prediction. So for that we will use st.button. If st.button, that is if we click on this button, then what will happen? So what will the text on the button display? Let's give it like predict CO2 emission emission emissions. And when this button is clicked, what will happen is that we will make, first we will collect all the inputs. So for collecting the inputs, let's make a variable named input features equal to, we will take it in a np array form, and within the bracket we will pass on all the variables that we have. We have make, we have model, val, vehicle class, and let me copy it, engine size, comma, cylinders, transmission, and then next variable is fuel consumption, city. Like basically you need to just take all the variables that you have placed for input, comma, highway combination, and this last variable. Now we would just reshape it just to avoid any kind of errors. Okay,
Fuel type, fuel type is not like
which one?
fuel type call
Fuel.
input, fuel type input.
Okay, I missed that, right? Thank you. Thank you. Where should it be placed? After transmission. Okay, thank you. So we will reshape it to 1 comma minus 1. By 1 comma minus 1, what we mean is that this input features that we are giving to the model, it contains one row and the columns it will detect automatically. Okay, so after we get the input features, we would do model dot predict, and we will predict based on the input features, right? And now these predictions need to be stored somewhere, right? So for that, let's make a variable. Let's make it prediction equal to yes. So we are assigning the prediction value in the model.predict function. So after that, we would write this output, right? We would write it using st.write predicted CO2 emissions in gram per kilometer is of is, and we would just write the value prediction of 0. It will take the first prediction. Okay, so with this we are done with the front end of application. I don't know if there is any error, but let's find out. Let's first run it. So we would open a new terminal, and in the terminal, let me see. In the terminal, we would have to write this command: streamlit run app.py. My file was named as app.py, so I wrote it as app.py. Whatever is your file name, just specify that. So I think yes. So you can see the application will be live. It's loading. Okay, so see, we have these input values, and this plus minus will help in incrementing and decrementing the values. It is already set to a minimum value, right? So as a result, what happens, we cannot decrement it further. So let's put some random values for 23.45 probably, and cylinder, let it be 4, transmission something, fuel type also anything, fuel consumption per city, let it be 60.56, for highway let it be 70.67, and for combined we can also give any value, 69.78, enter. Fuel combination, let it be something around 70.89. Okay, so we have placed all the inputs. Now let's predict. So see, the prediction came out to be a 737 gram per kilometer as the CO2 emission. So now you can say this whole project is ready, and you can just push the code into your GitHub, and you can deploy it with services like Render or Streamlit. Anything would do. And if you want a good scaled app, then you can also use Google Cloud Platform. And before you push your code to GitHub, a thing that is recommended, I would say, is you can just open another terminal and you can install all the packages that you have been using. This would help in building your application. Okay, so for that, pip freeze, you need to write this command, then this arrow, requirements dot txt. And before you make this, you will have to also create this file. So let's create this file, requirements dot txt. Yes. So now let's run this command, pip freeze requirements.txt. Yes, now see, all the requirements have been there. So when you will use any deployment service, what will happen is that it would install all these dependencies that are required, and then deploy your application. So with this, we are done with the project for today, and I think I could explain you. If you still have any doubts, you may ask me.
Okay, so are we getting source code?
Yes, it would be provided. Don't worry about that. Any more
and
queries?
and I have a request. Please, we will get this recording.
Yes. Even the
Yes, you will
recording
be.
will be given.
It's more about interesting. I have learned new things about terminal, recording terminals, and what is that pickle? I
What?
learned about pickle also. Pickle, import pickle language.
Can you speak a bit louder? You are not
Hello,
audible.
hello,
Yes?
hello.
Yes.
I have learned the new one today. Import pickle.
Hmm.
Understood very well.
Okay.
Explaining was good.
So, is the import not happening? Is that the problem?
No, no. I have learned with a new skill. New
Okay. Thank you.
very
Thank, thank you
very
that I was able to add some value.
no. And I have to review this record session and I have to implement. No, I also okay. I also want to implement it.
Uh, what did you say? The last line?
Uh, I want the code and recording system.
Yes. That would be provided at the end of the 3 day session
Okay,
together.
thank you,
Okay.
thank you.
So you won't face any problem. Is there any more query? Okay. So I think we are done with the session. If you have any questions, you may ask, or any feedback or anything. To final deployed app. So my query is whether there is some way to work with non-encoded values as well. Yes, you can do that. You can use some drop-down values to take in the inputs and then encode it within your code. That is also possible. Okay. So I don't think there are any more questions left. So Rishi, shall we wrap up this session
Yes,
or?
I guess. Yes. It is. I guess no one has any question.
Okay, thank
So
you so
tomorrow
much.
is the.
Thank you, everyone.
Yes, thank you
Yes.
for the enthusiasm that you showed. Like, it made me feel good as well. Thank you.
Thank you.
Thank you. Now we can end this session.
Yes, thank you, Shibu. Do join for day 3 too.
Yes, that
Tomorrow,
will be
Rishi,
an
Rishi and
interesting session.
Aishwarya will be taking. They will be doing a hands-on project on decision trees. That is a classification algorithm. And today what we did, it was a
Regression.
regression algorithm. So anybody has any doubts, any queries or anything? If not, then you may leave.
Good evening, everyone. Everyone, good evening. Good to see that people are still joining in the day three also. Normally, people are tired in the by the day three. We'll start at 7:35. Let's wait till 7:35. So, okay, let's start. I will screen share it. Okay, so today is our third and last day of our ML workshop. Today we are going to do a hands-on project on decision trees. Basically, this one will do a classification project. Yesterday we did a regression project. You did a very good job. So let's go next. So I think about me now. Everyone knows about me by now. I can see the very old audience. Let Aishwarya introduce herself.
So, good
Aishwarya.
evening, everyone. My name is Oshorja Shovidi, and I'm delighted to have you all today. If you did like to connect with me after this session, feel free to reach out to me on LinkedIn. Rishi, can you just show the LinkedIn?
Yes, surely. Mhm. This is a LinkedIn. You can go and check it out, guys. So,
So, we should start right now.
okay, I'm starting. So, about today. Today's agenda is first and foremost understanding the problem statement. Then we will know about the data set. We will do all the data preprocessing, visualization, model building, and evaluation. So let's start. So today's problem statement is to predict the likelihood of a stroke occurrence using a patient demographic, health, lifestyle data to aid in delivery. Basically, we will detect whether a person has would have a stroke or not with some like input features like gender, age, marital status, residence type. Health metrics are there like heart disease, hypertension, BMI, glucose, and lifestyle includes like whether the smoking status, work type. I will just go through the dataset once. This is our dataset. So we have, so you can see these are the our input columns from ID to J, gender, age, hypertension, heart disease, until we have smoking status. These are our input columns. These are input columns, and this one is the output column stroke. One represents whether yes the person will have stroke, and zero is the person does will not have stroke. So these are basically the data set. I hope you understood what we are going to do. Okay. So next, okay. So next we are going to do so overview. So what are we going to do now? Instead of saying all this, I will just directly jump into the code and show you what we do. It's all the same processes. So let's start directly to coding. Okay. So first and foremost, I have to load the data. Just a minute. Let me see the data set. I guess this is it. Yes. Let me just rename this so that I can have a little bit. Okay, like stroke. Okay. Okay. Now we will start as usual importing some libraries. First and foremost, we need import pandas as PD. Pandas, you know, it helps in some data operations, reading files and everything. Then import NumPy as NP. Then we can have a okay print split that model selection import print test split. Okay, now we what do we have? Okay, Another we will going to do is from like one thing, embed nothing, learn dot uh, oversampling import smart. This one is going to show when this is needed. This is basically needed for oversampling. This one I'm going to show you in code. And all these data set, this is for train test split, Pandas is for reading the data sets, and Excel also, and data operations basically. NumPy is for mathematical conditions. So you might be thinking that do we need to memorize all this, like all these imports? I would say you don't have to memorize all this. I can just able to write because I've been doing this for a year. And so for this you can just go to sklearn library. Suppose you want to know the import for sklearn for suppose model selection. You just go and you will get all the syntax here. You don't have to memorize. After just writing, you will just get the code. For suppose sklearn linear regression. Suppose you go sklearn linear regression. We'll get the all the documentation along with the code. See what you need to import, just everything is written there. This one I just show you example. In the first you don't need to memorize all this. I just know, so that's why I wrote. At first I also couldn't remember all this. So let's start. If any more libraries I need, then I will come to here and just okay. And just now let's read it. Df is equal to pd dot read csv. Yes, stroke dot csv. Okay, just a minute. What is this saying? See the changes. Okay, now df is stored. Let's see df. Let's see the data set. Okay, this is a data set. As you saw, I already show you. I will again give an overview. You can see gender is there, ID is there, age is there, hypertension. 0 is for no hypertension, 1 is for yes. And heart disease is also there, ever married, work type, residence type, average glucose level, BMI, smoking status, stroke. So, okay, now let's understand more about the data. Suppose you want to know, like, what are the unique values of smoking status are there, like formerly smoke, never smoke, like how many unique values are there in the column. If you want to know this, you have just tried to write this smoking. I will just copy this and paste it, and you will write just unique. Here you can see what are the unique values the column smoking status contains. Here you can see formerly smoked, never smoked, smokes unknown. Similarly, if you want to see for suppose work type, you will get to know from here. You can get to see like what are the unique values are there: private, self-employed, government job, children, never. So these are the like basic things I wanted to show you. Now let's proceed. Now, after seeing this data set, the first and foremost which comes to my mind is this whole data set. I don't think ID will create a certain impact in my model training. So, what I am going to do is just drop the ID column. Okay, df dot. So, from here, actually, data preprocessing starts. So, I will just write here df dot drop, and here it says see. This is the beauty of Colab. It just already knows what you're going to write. It's actually AI. So I'm just going to do, and if you want to know the meaning, drop means it will just drop the ID column. Axis equal to 1 means it will drop the column. If it have been 0, then some rows. And in place equal to true means the dropping of this ID column in this data set is being saved to the DF. So it is saved. So this is the meaning of in place too. If we haven't specified this, then the job wouldn't have been worked. It wouldn't have been saved in the DF. So I'm going to write this. If I want to see if this has been dropped or not, let me see this. I will just write some three only. Okay, three only to see. Okay, I can see the ID column has been dropped. Okay. So next what I can do. So next I want to see, suppose I want to see the info of the data frame. Okay, let's go. If I just write data.tf.info and just shift enter, you can see like what are the columns, like gender contains an object data type, age contains integer, and hypertensions contain integer, and all those you can see ever married and all those contains integer. So from looking here, I can understand the first and foremost. I think you have got by now that first and foremost, the rule of any machine learning is to convert any object data type to integer or float data type, because machine cannot understand objects. It only understands numbers. So this is a thing we need to do. I can understand this. So okay. So before converting that, we have to do all more checks, like if to see how many null values are there. Okay, df dot is null dot sum. Okay, now let's see. Okay, now we can see the none of the columns contain except the BMI, and BMI contains null values, 201 null values, which is actually huge. Suppose if I got the null values as until like 7 to 10, I would have ignored it because 7 to 10 rows would have impacted the dataset so much. But since it is 201, so I have to do something with the like null values. I cannot just remove it. So I will just replace the BMI values with the average values. So let's do it. BMI, df.BMI, df.BMI, uh, replace, replace any, just a minute. Replace, and this it is giving the this. What is doing is just replacing the null values with the mean. Okay, let's see if it happens or not. Okay, let's see if it is done or not. Let's see first. Okay. Okay, now wonderful. See, you can see the null values have been removed. Now there are no null values. So suppose in here in observation we can write there are no null values present now, since we have replaced it with mean values. Okay, so this one is just a conclusion. Now what I can do, I can just check the statistics of data. It says from df.describe. You can see these things. Okay, suppose yes, for age the count like 5100 is the number of rows basically. The mean values of age, the like column age, mean, standard deviation mean, the 25 percentile of this, 50 percentile of this, 75%. You can understand everything from this, like this data set. So this was something. And now what I need to do, I think this was the basic checks I did. Now what I will do is start level encoding. Let's start. Okay, I think I have not imported that, so I need to import it from here. Okay, from Scikit-Learn dot pre-processing import not level encoder. Okay, so I did it. And also for the metrics also I need just from sklearn dot model sklearn dot metrics import confusion. Okay, see it already is giving me here. Okay, nice. This is the word of auto completion of code. I will just run this again. Okay, now we will do the level encoding part. Okay, now for the level encoding, instead of writing every like column by column, I will do it in a for loop. Like, uh, you can just ask me if anyone doesn't know the for loops. I will explain you. Df dot columns. If df I okay df dot I dot d types. Now what these d types do? Okay, before I will show you it. D types. Okay, just let me show you before this. Like what these D types do. Suppose I'm just executing D types. It will just say what are the like uh, where what are the like whether it is an object or integer or everything. It will just show like gender is an object variable data type, age is an float integer like these things. So I will just start. You understood what these D types? Right, just df dot 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 columns. Okay, not just optogram related. This now what this code does, it is just going to each and every column, and checking whether the type is object or not. If it is object, then it will just label and code it and just fit transform it. I hope you guys understood this statement. I'll just run this. I think it is done. I will just see this. Uh, Suppose df.dtype only I do. It should all be either in float or integer. Yes, it is done. You can see all are been converted into integer or float data type. If you want to see in data frame format, you can see all this. I hope it is clear. No doubt till now. If any doubt, you can send. Yes, this is all converted to. It's all label encoded. So we have converted to label encoded. Now we will go to EDA. So I will give just a minute. I will just write EDA. And this will be taken by my teammate Aishwarya. So I will hand over to Aishwarya now. Again, after then I will come. Okay,
Okay, so
Aishwarya, madam.
huh. So EDA is a step that has to be done before we put the data to the training. So I'll just share my screen and share the code. So before sharing the code, I will give some theoretical definition. So EDA stands for Exploratory Data Analysis. It is a process of analyzing, visualizing data to uncover patterns, detect anomalies, and prepare it for modeling. So the raw data that you got in the CSV format, it is actually very difficult to visualize. And for complex data, you actually need the visualization, or you cannot like find the suitable algorithm to train it. So for this, we need EDA. So we will start. Just refresh this page. Or I will just rerun it, or I will sit in keep it up. For EDA, we need matplotlib because EDA is all about visualization. So we need to plot charts, or else or what is visualization in code. So first, I will import the necessary libraries, that is matplotlib. Then we will see at the columns, what are the columns present in this data. So just run this command. Yes. So we have gender, age, hypertension, heart disease, and ever married columns. So first, let us, for understanding, let us plot a gender distribution graph to understand how many female or male were actually interviewed for creating this sample. So we'll plot a pie chart. So first we will note it down, like how many female were actually there. So I will run this command, gender value counts. So as the data was encoded, so the string, the object type data was converted to number. So as you can see here, 0 represents the female. So there are 299, 94, 2994 females. 1 represents male, that is 2115, and 2 represents, it is unknown, so we just ignore the 21. So we will store the value in a list, that is 2994, 2115. Then we will set label and male. Then we'll start the plotting. Dot pie temp the value, then labels equals to label. Then autopcity. This autopcity means the number of digits that will come after the decimal. 1.2. Let's take that only. Okay, we are done, and then we have to run this command, or else the plot will not be shown. Oh, I made a spelling mistake here. Let's just remove this. Okay. Okay, this is the thing. So the number is not shown because I removed it. Maybe there's some kind of error, so I'm just leaving it aside. I will check it later. And we will also need to add a little bit of title details and all. So we will add a title. And that is it. So after the gender distribution, we can also plot the graphs for the pie chart of other columns also, like residence type, to see how many people live in rural areas and urban areas, average glucose level. So it's easy. So I'm just leaving it. Now we will next move to the next type of graph, which is actually very important. It is the correlation heat map. So for plotting heat map, I need to import another library, that is the C1. So I'll just put tab, run it. So once we import the C1 library, we need to calculate the correlation coefficient between each of the columns that we see. Like we have to find the relation between each of the columns. So for that, we need to calculate the correlation coefficient with the coarad function. So we will calculated like this. Coefficient equals to df dot quad. This calculates the correlation coefficients. Then we will plot a heat map. So for that, SNS dot heat map, correlation coefficient is the value. And not true means like if we give and not true, then the values will be displayed. And then we will just give a title to it, correlation heat map. Heat map, then show. Yes, so you can see it's very dirty. So I just increase the like specify the size of the plot. So we can do that with the help of plt.figure figure, and we can specify the size. Fig size here 10 is the width and 10 is the length, but I need it smaller, so I will just make it 8,6. 8 is the width and 6 is the height. So I'll run it. Still remains very bad. I'll just add another thing, that is the line width. I think this will make it much more clearer. Line width 0.5. Still it's so clear. Let me
Just edit the figure size into 10:8 or something. It will be
okay,
better.
comment. Yes, this one is clear. So as you can see, this is a heat map. Here the correlation coefficient ranges from +1 to -1. So +1 means it is perfectly matched, means it's just perfectly matched. You can see the diagonal thing is perfectly matched. Then at 0, it means if the correlation coefficient is 0, it means that there is no linear relationship between them. And -1, it means it is inversely related. That means if one increases, the other will decrease. Now we will see some notable correlation coefficient from here, like the positive correlation that we see over here in the age group. Age age to ever married, it is 0.68, so it is pretty high. So age and ever married are positively correlated. That means if age increases, the chances of being married is increases. So it is actually true. So we see from this we can actually say that. So again we move to the work type. Walked up, you can see that there are quite some pitch black minus 0.36, which means it's a heavy negative correlation with age, with ever married and BMI and smoking status. It means a certain type of people working in a certain uh, type like government or self-employment. So they have a higher chances of having these higher BMI or smoking, like higher BMI or smoking status. So then we see the stroke row. So here we can see the columns that have the maximum influence on the stroke. Like here, age has the highest correlation with stroke. That means it just says that if the man is older, he is more prone to stroke. So from this we can just say like that. So this is the this is the need for correlation heat map. It is very important for complex data. It becomes more important. Now I have just noted down the correlation outcomes in somewhere in the PPT. So I'll just show you in case I have forgotten any of them. Yeah. So the key insights from the correlation heat map. So the first is strong correlation. Age and ever married are highly correlated. I told you. BMI also has a positive correlation with ever married. You can see over here the BMI has a positive correlation with age and ever married. So strong risk factor. Stroke shows moderate correlation with age, hypertension, and heart disease. Like here, I've also already told you, like age, hypertension, and glucose level. It has a high correlation, not that high, but it is pretty moderately high. So it just shows that if a person is has heart disease, is older in age, has a high glucose level, so he is prone to have stroke. And also work type observation, like lower work type values, example government job, never worked, have weak negative correlation with age, BMI, and ever married. And also the actionable focus, like older individuals with high BMI, hypertension, or heart disease are prone to stroke, and age and health factors are stronger predictors of stroke than lifestyle or life or work related features. Like see in this stroke, the stroke row, the average glucose level, the age, the hypertension has more correlation than residence type. Like the residence type is 0.015. So it has almost no relation with stroke. So it doesn't matter if the person is living in the rural or urban area. So it doesn't have any influence on if the person is going to have a stroke or not. So after this correlation heat map, will plot another histogram. To, as you can see, the stroke has a high correlation with it. So we like to like visualize this relation more depth with the histogram. So for that, I will also use the CNS library. So SNS his plot x age, that's the x-axis, data frame I will mention, df, then this stroke, then green is the number of interval. I'm putting it to be 10 to make the graph more clear. If you want more specific, like more detailed, then you can put the bin of a high bin value to be higher. Just increase the size. Then we can also specify the colors over here with palette. I will put blue and red. So here blue will stand means the person has no like is not prone to stroke, and red means the person is prone to stroke. So I will then give a title to it. Title, this is age versus stroke histogram, and I will just show. I think I made a spelling mistake here. Oh, I forgot to put the stroke in single quotes. Okay, it will be beans. Yes, so this is the histogram that we get. So if I make the bins much more higher, we'll get a more compact thing. So I reduced it. Yes, it is more compact. So I'll just keep it to 45 only. Then here we can see that 0 means the person is not prone to stroke, and 1 means is prone to stroke. That means we can see that if the age is higher, the person is more prone to stroke, like the redness is more here. So from this histogram, we can get an idea about the age and stroke thing. So after this, we can actually visualize this data, and visualization is very important. Like according to this, you can also choose an algorithm. Like here for this kind of after this visualization, we choose decision tree. So like this for complex data, we have to like visualize first, then choose the algorithm accordingly for higher accuracy. So I will just ask Rishi to continue with the training procedure.
Okay, thank you. Please uh, stop. Yes, thank you. I will share the screen now. Okay, you saw the EDA part. Okay, now I will just go. Okay, now the next thing I want to show you. Let's start. Okay, next thing is oversampling. Yes, one thing I want. Okay, now one thing which many persons tends to forget. I will wait. I will show you. Okay, let's first partition the dataset in input and output columns. Df dot crop stroke axis equal to 1 and y is equal to the df. Okay, so here just let me show you one thing. pd dot pd dot I want to spelling mistake here. Okay, now just see one thing. Okay, now see here one thing, like in the output column, what just see here now is the no stroke, having the possibility having no stroke in the data having 4,861 samples, but the for possibility for having stroke is only 20. Now if I just go on just to train with dataset with this imbalanced dataset, now the accuracy with which is will produce is totally unreliable. So for anything like in classification, before going to training and testing, first we need to see like whether the output columns are totally balanced or not. If it is not, then the accuracy will be totally misleading. So what I'm going to do now, I'm going to just like oversample the one data set, like so that the two classes can have same number of data points. Like no stroke has also 4861, one also 487. So I will try that. Let's see. First, let's initialize this smooth random state. Random state is for just fixing for among the number of. Yeah. Okay, now let's start smooth x comma y. Okay, now let's see what happens. Now what I will do is again I will convert this into a data frame. pd dot data data frame. Okay, this is y1. Now let's see the value counts. Dot. Let's see the value counts now. Okay, now beautiful. Let's now you can see here that these possibility having no stroke 0 is 4861. It was 4861 also, and this one which was earlier 249 has been upsampled to 4861. Means we have included more data points which is having like the stroke as 1, which is 1. So now we what we did is just we oversample the data set, preventing from any preventing from any imbalanced data set. So now let's just go on for training. Okay, next test. White one. Okay, beautiful. It is giving me suggestions. It is saving your time and my time as well. I will just write the here so that when you will get the code, you just properly understand which one is doing what. Okay, wonderful. Let me. I think I executed this right. Okay. Now what I will do? Okay. Now decision tree. So before going to decision tree, let me give you a brief of what actually decision tree does. I will just give you a brief of this. Just a minute. As you know, I like to explain everything with examples. I've just took out a screenshot and I will explain you with an example only. Suppose there is one condition where it says age is less than equal to 15. If it is no, then it will go to this branch. If it is yes, then it will go to this branch. Okay. So like this, some tree formation is created. So suppose I have given an input like age equal to 21. Okay. Now come on, I'm checking this. Suppose is the age is less than equal to 15? Is the age 21 is less than equal to 15? No. So this will come again to this one, this branch. Okay. Now in this branch, what this branch says, age is more than 15 and age is less than equal to 21. Okay. So I will again check with the condition whether the age 21 age equal to 21 falls under which condition? Age equal to 21. I can see this fall under the yes. It falls under the yes category. So again, this will branch out to this node, and this one we get finally get the outcome that it is the student is in college. So this one I gave you like a short example, like a very easy example, what of how the decision tree works in any data set. I just here with the just in two branches, there can be more than two branches also. Basically, this is only the funda. It just narrows down the decisions and comes to a final outcome. This is the basic geometric intuition what decision tree does. Instead of just giving too many formal definitions, I decided to just give the examples so that you can understand more. Just a minute, I just will drink a water. Okay, now let's go with the decision tree. Okay, decision tree. Now I have imported. Let me check it once. I don't think I have encoded. Okay. This one is the actual procedure. No one just remembers everything they have done. So they just whenever they need, they just go to up and just write. So I just showing you the real time what are the conditions of developers here. So here you can I just imported. It is the this is the beauty of collab. Everything comes in the AI suggestion only. It saves my time and your time as well. So let's go decision tree. Okay. I will do a model. Model is equal to decision tree classifier. Okay. Just I will show you this one. I will just do this. Okay. Model is done. Model dot fit. Now, what are we training actually? We have partitioned the dataset with training and testing. So of course we will train the data set on the training portion only, not the testing. So here it is, X train and Y train. We are training it, and something will come. Yes, so the model is ready, trained. Now let's go with the prediction. What the prediction will give. And on what and you guys only tell me on what data set the on what portion of data set the model will predict. Obviously on the test version.
Train. Test question. Yeah, yeah,
Test,
test question.
test. Yes, exactly. Thank you. Because it is doing on the testing data set. On training, it is doing the training part. On testing on only, we will do the prediction and check whether how much is the accuracy. Okay. So we have done, and now the next part. So what is the next part? Next part is nothing. Just get the accuracy done. I will just print the accuracy first. I will print the accuracy. This is score, and let's see what is the score. Okay, I think 90%, 90.12. It's not that bad. It is good only. Suppose you might be thinking, if we haven't just upsampled, what would have been the score? So I will just give you an example. Just a minute. How can I do this? Okay. Okay, let's just change this to X and Y. Then it will be on the like just the upsample data. This now will be training on the 0 and 1. I hope like at least some accuracy should be decreased. Now let's see if there is any change or not. We are doing on the not upsample data. There is a mistake. Just a minute. Just a minute. I will just here write the code on like x equal to df stroke. Just a minute. Have a build and just a second. Let me see this one and let me see the count of y. Okay, I have to just put it up. Okay, now this is the like old one. This is x and y, I guess. This is, let me see again now. X model distant reclassifier model extend. Okay, now let me do this again. Y spread. Okay, there is no such difference I can see. 90.41. Now if I change this is to x1. So in this dataset, this might have been not good, but oversampling is always a good practice. Trust me. In many datasets which I've seen, the accuracy has been increased tremendously. Now about this dataset, it might have just no no, just change the model one.
Change the model, sir.
Mhm. Mhm. Okay, so this is accuracy. Okay, anyone is saying anything? Okay, now let's print the confusion matrix. Now confusion matrix, remember I told you on the first day only, like what is the confusion matrix? Since it is having only two labels, so there is just a 2 cross 2 matrix. Suppose if it had like 3 or 4 columns, it would have four. If it has three output columns, then it will 3 cross 3. If it was four, it was 4 cross 4. And in one thing, confusion matrix, you have to see like this: the right diagonal, which is also called the primary diagonal, has to be maximized as much as possible. And what does this means? I can show you in the this one also. Like let's go, which I've done. Okay, see this one is the false negative, this one is the false positive. So here you can see this one is the false negative value it came, this one is the false positive. So if I want me to explain this, suppose False negative means the actual is, suppose it is 1 and 0 and this is also 1 and 0, means the predicting means actually it is the 1 means actually the person has stroke, but the prediction it is saying that the person doesn't have stroke. So this one just is what the meaning in the 118. And what is the 75? 75 meaning is just this one, like this one, false positive one. Like what I want to mean you like this is like the actual the person doesn't have any stroke, but the predicted has showing it is stroke. So this one is what the confusion metric means. And if we can print the classification matrix also, just a minute. Okay, now let's see this. Okay, there is a bracket missing. So this one is the like classification report. Remember the precision recall F1 score I told you in the first day itself. This one is the formula. So here it is all just calculating in the formula, and it is just calculating, and we are getting everything. So this is it from the model, and next we will now just locally deploy it. So again, my friend Aishwarya will continue. Okay, Aishwarya.
Okay, so previous day you used Streamlit in VS Code. Now we will use it in Google Colab. So it is a bit different, but the main thing will remain the same. I will share the screen and I will just refresh the page because it is causing some problem. Just wait a second. Actually, I was facing some problems, so I couldn't run the cell. So first that we have already created the model. Now we need to export this model so that we can use it in other purpose also. So for exporting the model, we will have to import the pickle library. So I first import the pickle library, then I'll run it. So now I will export it with this command. Open model. We will name our model. I will name it model stroke .pkl. Here we will use WB because we are writing in this file. We are exporting this. So it is write binary. We will see that when we will use this model, we will use RB. That means read binary. Dump model comma. I think the model it is named model 1. Just change it.
Yes, I changed it to model 1.
Okay, okay. So it is
Hmm.
model 1. So we can see in the file takes time to load. Oh, why it's taking too much time to load. Yes, so you can see there a file is created called model stroke.pkl. So this is our model. We have exported our model. Now to use this model in Streamlit, we will create a file called app.py like previous day. Name it app.py. Okay. Now for using Streamlit in Colab, we have to first install the Streamlit framework here. So for installing it, I will use this command and Q. Okay. So this is installing the Streamlit and it is done. So after this the Streamlit framework is installed. Now I will add a few lines of the code. I have copied the command actually this command. So I will run it and it will give an address. We will need this address later. I will show you why. So first let us go into the Streamlit framework app.py. So previous day the Streamlit was explained to you pretty nicely. So I'm not writing the code line by line. I have prepared the code previously. So I'll just copy paste and explain. So wait, second Streamlit. Okay, I prepared the file. I'll just explain it to you. Don't worry. Go here and paste it. So here first we import the libraries Streamlit, Pandas, Pickle, and label encoding. So first we load the train model. I told you now we are using this model. So here we are using read binary and we are using load because we are loading, not dumping. Then we set a title, we set a header, then we will take the inputs. So the inputs are stored like for the gender, we are storing the input in gender variable, and here we are using select box. In the select box, gender will be the title and female and male female will be the options available to us. Then a slider for age, 0 will be the minimum value, 100 will be the maximum value, and 25 will be the default value in the slider. Then hypertension again select box and likewise the others one also given. Then after giving the input, we are giving the input in string format, but we have trained our model in integer format. Remember we actually used the label encoder previously also to change the object format to integer format to train our model. So here as we are giving the integer input, so we have to also change the integer to string to integer to use it in our model. So with this encoder, we are again changing it like gender encoded. We'll have the 0 or 1 value accordingly, like 1 if gender is equals to male or it will be 0. Hypertension again 1 if yes or 0, likewise others one also is done. Then after we encoded the things, we will create a dictionary. In Python, dictionary has a key and a value and it is included in the enclosed in the second bracket. So here gender or the column name of the data frame of the actual data frame we had is the key and the value to it is the input that we are giving. So here we created an entire dictionary. Now we will the dictionary that we create, we will feed it to the model and we will get the prediction result. So that is what we did in the second part. Decrease the size. Okay. So here there will be a button called predict stroke. So when we click on it, it will first the user data will be fed into the model and we will get the prediction result. Then we will see if the prediction is equals to 1. If the prediction is 1, that means it's a positive case. That means the person is prone to stroke. And if it is 0, the person is not prone to stroke. So we just wrote that like if prediction equals to 1, then the model predicts the patient is at risk of stroke, and if not, then the model predicts the patient is not at risk of stroke. Or if there is a kind of error, it will just show the error. So now that we have, I have explained you the streamlit framework for this, we will start deploying it. So for deployment, we have to run a command similar to that we have done in VS Code, but a little bit change would be there. We will run this command. This command. So the only this part you ran in the VS Code. It was to just to run the file locally, but here we are also adding the local tunnel package. So the speciality of local tunnel package is that it tunnels your local server to a internet server. Like if for as much time as this cell will run, you can it will give a link. If the link is formed in my computer, and for the time being you can also access the link, and the password for that link will be this one. I will show you. First let me run it to be more clear. If I show you, so if it asking why, I just press y. Then it gave me a random link. So this is called the local tunnel link. I will click on it. Now it is asking for a password. So the password is the IP address that I got from running this command. So I'll just copy it and write it over here and submit it. Then as you can see, the Streamlit file that we created is opening. It takes some time. Okay, it is showing network issue because as it is pushing it globally, so internet has to be strong in this case. So I'll rerun it. Okay, this time it is nice. So I will put my specifications: gender female, age 20, hypertension no, heart disease no, ever married no, work type never worked, urban, glucose level I will make it 50, and BMI let it be 45. I never smoked, so never smoked. Now I will check it. Yes, look, the prediction is given. The model predicts the patient is not at a risk of stroke. Now now that you have predicted, you all can use this link and this password to open this same app in your devices also. I'll just share the link with you all in the chat. You can also see. This is the link, and I will share the password also. You can check also.
In first, it might show network error, but after you reload, keep reload, it will be fine.
Yes.
Okay.
So now if I close this one, you will not be able to access. So
Yes,
when it is
that's it.
running, it will be accessible to all.
Till the code is running, we can check it, else not.
Like if I give another result, I increase the age 72, attention. So if you have all seen, I will close this file. Or if you have any doubt, you can ask me also.
So more or less this was our session for today. I hope you guys could learn something out this total 3 days machine learning day workshop.
If it is perfectly working, then it is good. Now, this local
Yes.
tunnel can be also be used with Flux and everything. You can use it. So it's a very handy tool. Like if you're doing a group project and you need to like share the output, if you are deploying it locally, then your friends will not be able to see it. So with local tunnel, they will be able to see it. So you can use it there also.
But there is a catch only till your cell is running. The
Yes,
moment
yes.
it stops, you won't
It will
able to
show
access
error.
this.
Like
So this was just for just
if I
this one just
close
for
this.
temporary showing.
uh If I close it, it will show error after some time. Like it is showing connecting, and after some time, you just close.
Yes. So this was it
So if you
for our
have any
three
kind
days
of
machine
doubt, you
learning
can ask.
workshop. I'm proud of you guys. You like I can see 30 consistent people have constantly joined for the total 3 days. I didn't expect.
Yes, it is very appreciable, and we are very thankful to get you as audience.
Yes, very very thankful.
You have the quality, sir.
Thank you, thank
That's
you.
why we are doing.
Especially Shiva Chaitanya, you have been very engaging. Thanks for that.
Yes,
Thank
he
you.
listened to everything very nicely and asked
Mm,
doubt. Actually, it motivated us
yes,
a lot.
In today's
when I
section,
was,
I don't
huh,
have a doubt. At today's section,
thank you.
because
I
it's
was like,
explaining process very nicely, and the file, whether the code is running, and
বলছি যে
everything nice, sir.
সোর্স কোডটা কবে নাগাদ হাতে পাওয়া যাবে?
সোর্স কোড ভাই তুই আশা করছি 2-3 দিনের মধ্যে নিশ্চয়ই পেয়ে যাবি। আর আই থিঙ্ক
Within 2 to 3 days. Within 2 to 3 days.
ওকে।
ইয়েস, yes, exactly. So this was our whole. I think you got something from these 3 days. If you get any data set, I think you can start exploring machine learning. Now as you more practice and as you more see all data sets, you will just be able to learn more about the machine learning. This one we just show you this the just sample data sets. In real life you will get more problems data set and whatnot. So this was it. Thank you guys for joining so much. You stayed for 3 days.
Yeah, thank you everyone. So that's the end of the meeting. So everyone can leave. Yeah,
Thank you guys.
thank you.